All right, welcome back. We are still in the transformation section, chapter rather. Transformations. All right. So that the main thing we're doing is transformations. We've learned about translations, which is left and right, up and down. We've learned about reflection, which is reflecting across the X or Y axis or some line of your choice. And today we're going to learn about rotations. Now these look scary, but I have a cheat sheet, so I want you to be prepared to take a screenshot or to take notes on that slide where I have the cheat sheet for this. It's not that difficult if you just keep the cheat sheet handy. I would recommend physically writing it down so you can keep it as you work on these. So a rotation is a turn of a figure at around a certain point at a specific angle. Okay, so we have this point. It's like this string hanging on it, and we're going to take this thing and we're going to turn it around this specific center of rotation is what it's called. So the vocabulary center of rotation is the point at which it turns from, and then that creates this angle. Okay, now this angle, the ones that we're going to work with are 90 degrees, which is this angle, right? This 90-degree angle looks like it's creating 180 degrees, which is a full, from top all the way down to the bottom to where to be upside down, right? And then a 270 degree, which is basically 3/4 of a turn. So this is a fourth of a turn, or 90 degrees. 180 is a full turn, and then this or half of a full turn. So think of when you hear people doing a 360 dunk, they go in a full circle and come back around to where they started. So a quarter turn, a half turn, 3/4 of a turn. Okay, a whole turn would obviously just look the exact same. Save us some work. But all right, so this is just kind of trying to get you to get the idea of what it looks like. So we are looking at, I feel like I need to circle this so you can see. We're looking at this right here. So we have this point P, and it's connected to this thing, and we're going to rotate it 270 degrees clockwise. So if you think of a clock, the clock goes from 12 to 1 to 2 to 3, right? So clockwise goes to the right. Clockwise. Counterclockwise goes the opposite direction. Counter to the clock, right? That's how they come up with it. Okay, so as you can basically see from down here, they're starting us off here and connecting us to this point P, and then they're just going to rotate. And this note here is kind of a good example of just kind of think about it. If you rotated this specific thing down, then this little hole, the puzzle piece, would be here now. If you rotate it one more time, this little hole would go from here to here, and then once you get this full 270, this hole, so it would go from being on the left to being on top to being on right to being on bottom. Okay, so hopefully that sort of helps. So we end up with this, which is C, because that matches the piece. Okay, don't worry if that doesn't make sense. This will get easier, but it's just kind of giving you an idea of what a rotation looks like. So pause it and see if you can. I'll erase. If you want to pause it and look at this down here, you can. Okay. So, this is the confusing part that your book gives you, kind of trying to get you to understand how it works. So this is the counterclockwise method. Notice, so it's talking about counterclockwise. Don't worry, the cheat sheet's coming that I've made. So for a 90-degree rotation from here to here in the counterclockwise, right? The clock goes from 12 to 1, so it goes right. So counterclockwise, what happens is the value that was the Y value here is equal to the negative So the x value becomes the negative y value. So whatever this point here was, it is the negative down here, okay? And then when you do a 180, everything is backwards, so it's negative x, negative y. That one makes the most sense. And then this one here is your x value becomes the y value, right? So however many x was here, it comes over here and becomes your y, and your y is the opposite of your x. So your x was this many, and now that comes over and becomes your y. So does that make sense to many of us? Probably not. If you want to pause and study this until it makes sense, you're more than welcome to. I've never committed this to memory, just to be honest with you. I actually have this picture on my phone, a similar one to this. So this is the screenshot / pause and write down cheat sheet. Okay, and we're going to use it here. Notice that once you know one set, okay, and I have memorized these before, but I just never keep them in my brain because it's a whole nother year before I do them. So just keeping this cheat sheet's a good idea. So notice that the 90-degree counterclockwise, like we talked about, makes the negative y become your x value, and the x value becomes your y value. That's what that means, okay? And don't worry, we'll do an example. But notice that this 90 degrees, so let's look at what that looks like. Hopefully you took your screenshot because I'm going to mess this up. Okay, so if I have my 90-degree, okay, let's just look at this. So if I go counterclockwise from here, right, 90 degrees here, okay, then that would be the same as going clockwise. So instead of going a quarter turn, we're going to go 3/4 of a turn, right, back around. So that's why it says this down here is the same as the 90-degree counter. So basically this and this are the same. Okay, so hopefully that makes sense. If not, the practice of this will get it to where it's very easy for you, I promise. Going back, we have to look at our counterclockwise, which was 90 degrees, so negative yx. So take a picture of this screenshot, and you'll be good to go. All right, guys, have a good one. Okay, so we're going to do one. All right, so first of all, the vertices, let's read it. The vertices of a trapezoid are -4, 2, -3, 4, so we have some points. So we're going to plot those really quickly and see what we have. So we have -4, which is on my x, -4, 2. So I want you to be thinking about where that would be as I go. We have -3, 4. We have -1, 4. And we have -1, 2. That can't be right. -1, 4. -1, 2. I guess it is true. Okay, we just have a funny looking one. Okay. So here's my little trapezoid. All right. So we are going to rotate it 180 degrees. It doesn't matter what direction because 180 degrees is 180 degrees, and they are both -x, -y. So really quick, there's two ways to do this. One is you could look at each point, or I think the easier way is just to write over here -4, 2. Okay, that's my first one. The second one is -3, 4, -1, 4, and -1, 2. And then we're going to make our rotations. And remember, basically all we're going to do is do the opposite of x and the opposite of y, as it says right here. So we're going to go 4, -2. And notice we didn't move them, okay? So the other 90 degree when we would flip them. So let's say this is the 180 degree. So we have, this one would be 3, -4. This one would be 1, -4, and this would be 1, -2. So now we can just plot these 4, -2, 3, -4, 1, -4, 1, -2. And our new trapezoid looks a little something like this. Okay, so that is the 180. All right, now just for fun, we're gonna go ahead and do one more. We're gonna go ahead and I didn't really leave I just decided here on the fly. Let's do one more at 90 degrees counterclockwise. Okay, so 90 degrees counterclockwise. So we have to look at our -yx. So this one would be -y, x. Okay, and that's what our image is going to look like. This one, the red one, was -x, -y. Okay, so let's do this. All right, so my y value goes negative and becomes my x, is what this is saying. So this becomes my -2. So my x value is now my -y value, and then my y value is just my x value. Okay, so again, the x value is my -y value. So my -y value is 4, or -4. So -4, and then just the x, -3. And then we have a -4, -1, and then we have a -2, -1. So back that up and watch it again if you want. Now let's plot these points. So we have a -2, -4. We have a -4, -3. We have a -4, -1. And we have a -2, -1. And this trapezoid rotated 90 degrees. Looks like that. All right, so hopefully that makes sense. And our point of origin would have been this here, because it's around about the origin. And this is the origin at 0, 0. All right, I know this is kind of confusing, but again, going back.